Okay, so math. Today we're talking about the discriminant. And before you leave today, I want to make sure you know what the discriminant is and how to tell how many solutions an equation has based on the discriminant. All right, you know this one, right? I hope you know this one. We're going to be using this one soon, and you're supposed to know it from regular algebra. If you haven't already memorized x equals negative b plus or minus square root b squared minus 4ac all over 2a, you can do it with that Pop Goes the Weasel song. How many of you heard it that way with Pop Goes the Weasel? Okay. So how many of you ever heard it this way? The happy birthday song, right? Happy birthday to you, happy birthday to you. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac, and it's all over 2a. So there's actually, I made a video where I found 7 songs that I could sing this to. So you sing it to any song you want, but you need to know that formula. All right, this part of it right here, that is the discriminant. But more specifically, it's what's underneath that square root. That's the discriminant. So it's b squared minus 4ac. So I actually have started training my students that when they're going to use the quadratic formula, they should always do that part of the quadratic formula first. Because if that part ever turns out to be what? What? Negative. If that part turns out to be negative, do you get that you're done? You don't have to do the rest of the problem because why? Yeah, square root of a negative is an imaginary number, and we don't do that to get real answers. Okay? So bottom line, if this part underneath here comes out negative, you can stop the problem right there. You don't need to have written everything else out. Okay? Now one more thing that can happen, of course, this can be positive or negative, or what's the third alternative? 0. If this part that's underneath here comes out negative, I think you all get that that means you aren't going to have any answers. But what happens if this part underneath here turns out to be 0? Like I find b squared minus 4ac and it comes out to 0. Then I've got the square root of 0. Is that a problem? No, it's not really a problem. What's the square root of 0 equal to? 0. So then do you get that this whole thing, it's like it's not even there? Because 0 is like nothing. So then, do you get plus 0 or minus 0 would be kind of irrelevant? Then all of a sudden the plus or minus doesn't matter either. And then when that happens, which was again when b squared minus 4ac became 0, then I have this. And do you remember before we talked about that would always give us something special? Do you remember what? I only said this once. You remember it? You got it. That gives us the vertex. So, would you please do what I just did? Circle that negative b over 2a part and say, remind yourself that that gives us, that's the little equation that gives us the vertex. So that means that the b squared minus 4ac part tells us a lot. If it comes out, if b squared minus 4ac comes out less than 0, that means negative, then you have no answers. If b squared minus 4ac comes out equal to 0, you only have one answer, and it's the vertex. And last, if b squared minus 4ac comes out anything else, we'd have to be a positive number then, right? Greater than 0. And then you just proceed as normal. And in a normal quadratic, how many answers do you get? 2. All right. So I'll do that again. All right. So alternate back to green. 2 answers. There. You learned the discriminant. It's b squared minus 4ac. That's the discriminant. So how do we use that? Well, if I give you an equation, and you're about to use the quadratic formula to get the answer, start underneath the square root. Do this part first. And you'll know before you even finish the problem, you'll know ahead of time, should I just stop right now because it came out negative? Or I got a 0, so this is a special one. This means that I have only one answer, and that answer is the vertex. Or if it comes out to be a positive number like it usually is, and usually we make it a nice number like 144 or something you can take the square root of, then you know you're going to get 2 answers. All right, let's move on a little bit. So here it is in words. It tells us how many and the type of roots that a quadratic equation has. Notice the discrimination does not have a square root on it. It is just the b squared minus 4ac. The most common mistake I'd say I have is kids thinking that they take this and then they have to square root it. Nope. The discriminant is just this part. All right, so of course the quadratic has to be in this form where you have a and b and c in it to be able to do this. All right, so if I give you the equation like this, that's vertex form. That wouldn't work. That doesn't give me a, b, or c. Okay, I'd have to multiply that all the way out to get general form first. Once you have general form and it looks kind of like this, x squared plus 9x minus 5 or whatever, now I've got a is 1, the number in front of the x, b is 9, and c is negative 5. So this only works with general form. Okay, moving on. So here is a problem, and it is in general form. And from what I just told you 2 seconds ago, do you want to do the whole quadratic formula? No. You want to start underneath the root, which is b squared minus 4ac. So right away, I would first of all, because you're new at this, you need to write it a few times so that you memorize it. Write b squared minus 4ac underneath it. Then write empty spot squared minus 4 empty spot, and drop in the right numbers for this problem and figure it out. So B's here, A is 6, and C is 4, okay? So then we got 9 minus, that's a pain in the butt, 24 times 4. 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9, 96. 9 minus 96. Do I have to finish? Yeah, unfortunately you do. Even though I know it's going to come out negative, I need to know what the discriminant is. The discriminant is negative, what is that then? 87? Make sure that's right. 87 plus 9, 97, 90. Yep, I agree. Raise your hand if you had negative 87. Okay, good. What did you just find? It's called the what? Discriminant. What does it tell you? It tells you how many answers you have. How many answers do you have? None, because they'd all be imaginary, because you have a negative underneath the square root. Because if you go back to this picture, that part right there just turned out to be negative something, and that means stop the presses, no more. I know it's no answers. But the discriminant was negative 87, and it told me there are no solutions. You don't even have to do the whole rest of the quadratic formula. All right. Please do this one all by yourself, and I want you to tell me 2 things. The discriminant and, therefore, how many answers this equation has. I'll pause while you try that. All right, so let's work this one out. B squared minus 4ac, empty spot squared minus 4 empty spot, and let's see. B is the 5, so it's 5 squared minus 4 times A is 3, and C is negative 6. Maybe some of you didn't catch that. C is negative 6, because there's a negative on there. Okay, I'm guessing that's where part of our problem is. 5 squared is 25, minus 4 times 3 is 12, and times 6. Probably 12 times 6 was a problem for some of you. 6 times 2 is 12, plus 6, 72. Is that right? Now, here's a mistake in the making. Do you get how there's 2 negatives in here? That makes that positive 72. then 97. How many of you had that? That's about half the class, a little less, well, a third of the class. Okay, so tell me, just let me help, so that it helps me teach other classes. How many of you made the mistake with the two negatives and forgot to make that positive? Okay, that was a bunch of you. How many made a mistake in your multiplying? All right, thank you. And I think that must account for most of the mistakes. Is there anything else that you know for sure you did wrong you can tell me about? All right. It's good to analyze your own mistakes, really. You learn from your mistakes. You really do. Okay, so if it's 97, how many solutions should it have then? 2. Good. Because you're going to put the 97 underneath the square root, you'll have 2 different answers, plus the square root of 97 and then minus the square root of 97, and you'll get 2 different things. All right. So this one, we rearranged it. Be careful. That's the only thing that's different. Turn it my way when you got it. And remember, give me the answer, and then how many solutions will you have? And if you can remember anything special about it, that would be extra impressive. You got the right answer, but the wrong conclusion. That's it. Nice. Yes. 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 And how many solutions is that? Yes. You did something wrong in your multiplying. Try again. Yeah. Your 0 is right, but the conclusion from that isn't, because the square root of 0 is not a problem. It's just one thing. Yes. And I'm glad you remembered that. Yes. It gets 0 and then 1 solution. That is correct. It said 0 giving you 1 solution, and even better than that, Mac, it gives you the vertex. How many of you remembered that it was the vertex? Awesome. All right, so if I do b squared minus 4ac, for those following along at home, b squared is 36 minus 4 times 1 times 6, which is 36 minus 36, which is 0. But it's really easy to think 0 means there's no answers. No, it means when you're in that great big formula here, you'll get a 0 right here, and that doesn't mean the whole rest of the formula is gone. It just means there's only one answer, and that answer is the vertex, because plus and minus 0 will just disappear. All right, yes?
You said that, not the numbers, you said that it was 4 times 1 times 6.
Did I do something wrong? Okay, hold on a second. 4 times 1 times 6. Oh, you're right. So what did I do wrong there?
It's 4 times 1 times 9.
Oh, I got fooled by this stupid repositioning thing. Thank you. I knew that it came out to 36, but I messed that up. Thank you. So this was 4a, and c is actually here because we rearranged these two on purpose to trick people, and it tricked me. Boo. Okay, this one. This one's a little different because its b is different. Try to figure this out. Don't overthink it. All right, here's what you should have thought. There's no b term. Wonder what that means. Does that mean b is 1? No, if there's a 1, there'd be a 1 in there. So negative x squared plus, I guess I'm going to say that the b is 0. That's what you should have thought. So then, if it's b squared minus 4ac, b is really 0 minus 4 times negative 1 times 9. So 2 negatives here make this positive 36, and that means there are 2 answers. Raise your hand if you had that one right. Awesome. Okay, I think you're catching on to how to use the discriminant. The discriminant tells you how many answers you're going to have. And it's just the smart place to start. You wouldn't think that the smart place to start on this formula would be like in the inside, although I have told you a few times that, you know, work your problems from the inside out, but you know, most people would start there and then would probably try to do this, but that's really where you should start, because if it's negative, you can just stop the whole problem right there. Okay, so let's look at this. This is a whole bunch of answers for the discriminant and how many x-intercepts that they're going to have. It says, using the data, draw a conclusion about how the discriminant influences the number of x-intercepts. Okay, I think we already talked about this. If they come out negative, you get 0. If they come out positive, you get 2 answers. And if you come out 0 for a discriminant, this is the hardest one because people think 0 goes with 0, of course. But 0 discriminant leads to 1 answer. And even better than that, that 1 answer is the vertex. Okay, so I think we've summed that up pretty well. How about rational versus irrational? That's different than imaginary, just to clarify. This is a rational number. I think we'd all agree that seems rational. That's a number I can relate to. I understand it. Okay. Irrational numbers. Is that irrational? No, I can understand that one. That one makes sense. But how about a number that goes on forever and never repeats? Blah, 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 blah. Okay, that's an irrational number. So pi is an irrational. And another irrational is something even as simple as the square root of 2. So the only kinds of irrationals we're probably going to ever tell you about are square roots that don't come out nice. Just to clarify, a lot of people use square root of 2 and then people think, well, that specific one is special. No, actually any square root that doesn't come out nice is irrational. So like square root of 9 would be fine. That'd be over here because it's 3. But the square root of 10 even, anything that doesn't come out nice, is irrational. All right? That's different than the difference between real and imaginary. Real numbers is pretty much anything. Even pi, for instance, is a real number. Imaginary ones are numbers that mathematicians made up so that they could solve problems like the square root of -4. Which, by the way, do you remember what that is? 2i, very good. Because the square root of 4 is 2, and you got to throw in the I to show that you know that you have a square root of -1 in it, which is imaginary. Technically, I is defined as the square root of -1. Have I ever told you the square root of -1 thing? I'm having a like blank in memory here. Okay, good. So then, do you remember that I squared? That was on your little top 16 test. Do you remember what I squared is? -1. Plain old -1. So if you ever see 25i squared, what does that really mean? -25. Because I squared is defined as I times I, which is the square root of -1 times square root of -1, so it's -1. So that's -1, so this answer is -25. All right, just wanted to get into some of that for a little while. Now, here's a quadratic. I can just look at the graph and go, boom, I know that this has 2 real roots. Can you do that too? Can you see where the roots are? All right, so those are real roots. But they could be, because remember how reals can be rationals? There also could be rationals. They could be decimals, like square root of 2. You can have an answer like square root of 2 touching here. It's just a weird decimal. All right, so look at this. I know the answer for this is -1 and +2. Okay, so that's a +2 and that's a -1. They are rationals. They are not irrationals. But if they had been irrationals, it would have been okay. It would still touch. Okay, if it touches once like this, remember what I was saying about that? If it touches once, then this is a real root and it's also the vertex. Remember how I was saying if you got only one answer, it was the vertex? That's a picture of that situation. So you know if you did the discriminant on this puppy with the -2 and the 1, and this will be a 1 in front, that you'd get 0 when you put it in the discriminant. All right, I think I've blown your mind enough, and this is all like optional stuff that you don't really have to know. So let's go to worksheet 7.4a. That is your homework. It's due tomorrow. We have about 25 minutes or so to work on it. Now let's look at the worksheet together, see if there's any parts we're going to skip.